Good morning, friends. So today we are taking a problem on inclined venturimeter. So it is given that determine the rate of flow of water through a pipe having a 300 millimeter dia placed in an inclined position where venturimeter is inserted having the throat diameter 150 millimeter. So the inlet diameter is uh, 300 and the throat dia is 150 millimeters. So the difference of the pressure between the main and the throat is measured by a liquid of specific gravity 0.7 in an inverted U tube, which gives a reading of 260 millimeters. So the reading in the manometer connected at the main and the throat is 260 millimeter, and it is having the liquid with the specific gravity 0.7, and the loss of head given that the main and the throat is 0.3 times the kinetic head of the pipe. So the given data is listed here. So diameter at the inlet D1 is 300 millimeter, that is written as 0.3 meter. Area at the inlet is now A1, that is pi d square by 4. So throat diameter is given as 150 millimeter, that is 0.15 meter. Area at the throat is now pi d square by 4. So that is this. Specific gravity of the lighter liquid. So that is in the U tube is 0.7, whereas the specific gravity uh, uh, of the liquid flowing in the pipe, so that is SW is equal to 1. So now the reading of differential manometer given is X is equal to 260 millimeter. So that is given here. So that is 0.26 meters. So the difference in the pressure head. So H is equal to, it is the difference of P1 by rho g plus Z1 minus of P2 by rho g plus Z2. So that is shown in the previous example here. So P1 by rho g plus Z1 minus of P2 by rho g plus Z2. So that is equal to X into SH by S naught minus 1, or it is X into 1 minus SH, SL by S naught, as the case may be. Now, taking that equation, H is equal to X into 1 minus SL by SW, because the liquid in the manometer is lighter than the liquid flowing in the pipe. So the liquid flowing in the pipe is water having the specific gravity 1. So the liquid in the manometer is having the specific gravity 0.7. So that is manometric liquid is lighter than water which is flowing in the pipe. So that's why it is 1 minus SL by SW. So we know the manometer reading given there in the statement. So substituting that, we are getting 0.078 meters of water. So we are having X in terms of manometric liquid, but we want head in terms of water. So that is this. It is also given that head loss is 0.3 times the kinetic head of the pipe. So it is 0.3 into kinetic head of water in the pipe. So that is V1 square by 2G. Now applying Bernoulli's equation, now we have sum of the three heads, that is the pressure head plus kinetic head plus datum head at section 1 is equal to sum of three heads, pressure head plus kinetic head plus datum head, and at section 2 we have the head loss also, uh, because by the time the liquid reaches from section 1 to section 2, there will be head loss. So that is given as 0.3 V1 square by 2G here. So but we know that the difference of the heads, so that is P1 by rho g plus Z1 minus of P2 by rho g plus Z2. So that is nothing but my H. So that is equal to 0.078 meters of water, and head loss is given as 0.3 V1 square by 2G. Substituting them, and we know that the continuity equation says that A1 V1 is equal to A2 V2. So V1 is equal to A2 V2 by A1. So we have here the ratio of A2 by A1. We know the area at the throat and area at the inlet. So substituting them, so that ratio of A2 by A1 comes to 4 there. So here we are getting V1 as V2 by 4. So substituting V1 in the earlier equation and simplifying, we are getting my V2 as 1.26 meter per second. That is velocity of the fluid at section 2 is now 1.26 meter per second. To calculate the rate of flow, either we take Q is equal to A1 V1 or Q is equal to A2 V2. So V2 is calculated and A2 is also known. Substituting them, we are getting Q. Thank you.